Welcome to the online classes about statistics concept. And this is a very useful chapter and very simple also. And we are going to learn this chapter up to our final education. And as you know that statistics is very useful in our daily life situations also. So if you want to measure the central tendency, one of the measure is arithmetic mean. Of course, we will use it as a more frequently as average. And average, the word average is the most frequently used word. Correct? Okay. So now we are going to learn about what is arithmetic mean or average for a grouped data and ungrouped data. Okay. As you know that from 8th onwards you learn about this statistics. Even from 6th onwards you learn it. And simply we can say average is sum of the quantities by the number of quantities. Correct? If I ask you what is the average of sum of first 5 natural numbers, you can say 1 plus 2 plus 3 plus 4 plus 5, which is 15. The total number is 5. So 15 by 5, which is 3. Correct? So simply like you can say the average. Okay. Here just observe it. 1, 2, 3, 4, 5, 6. So I represent the average diagrammatically. Observe this and understand what is average also. Okay. Now, the visualizing the mean, that's a very, very important. The arithmetic mean can be visualized as a balancing point on a scale of the numerical mass of the data. Set will land above the value of the mean, while the other half will land below. The mean may or may not be one of the numbers that appears in the number set. You understand it? If you observe this, so here the weight as it 5, correct? It balances it. The average balance it here. So what is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8? Just now I said it is 1 plus 2 plus 3 plus 4 plus 5 is 15, 21, 28, 36. Correct? So here if you consider it, that is totally is 36. Sum is 36 and the number of quantity is 8. So 36 plus 8. Correct? Okay. So means here 8 4s are 32 like him. So means here we can calculate the value before that. So when you observe this, here at 5 it balances the both the ends. Here at 6 it balances the both the ends, like the left and right. Clear? Okay. So this is the way you can explain or visualize the mean. Before going to visualize the things, all the things. In mathematics and statistics, the arithmetic mean or simply the mean or the average is a sum of a collection of numbers divided by the count of numbers in the collection. Very simple. Very simply you can say the sum of the quantities by the number of quantities, or sum of the observations by the number of observations, or you can say simply the ratio of sum of the observations and number of the observations. The collection is often a set of results of an experiment or an observational study, or frequently a set of results from a survey. In a survey, we collect the different kinds of observations, correct? So if you tabulate it, so that is called simply as class intervals and frequency. That is a grouped data. When you collect the total data, if you arrange the data even neither ascending order, descending order, that is called simply it's a raw data. So that is, or you can say as ungrouped data also. Correct? Okay. So when it is a group data, so how to calculate the arithmetic mean average? Just now I said the formula for arithmetic mean, that is mean equal to sum of all observations by the number of observations. Okay, for example, there are n observations, x1, x2, x3 and so on xn. N observations. The mean of these n observations is simply from the above formula, you can say sum, say x1 plus x2 plus x3 plus so on up to xn. The total number of observations are n, so by n. So mean equal to x1 plus x2 plus x3 plus so on up to xn by n. Of course, you can say a sigma xn by n. Okay, then what is the properties of average? That's a very, very important. When the difference between all the items is same and the number of terms is odd, then the average is equal to the middle term. Correct? So, for example, if you take it as 1, 2, 3, 4, 5, 5, correct? 6, 7, 8, 9, 10, 11. So, how many terms are here from 1 to 11? There are 11. 11 is an odd number. So, what is the mean of this data? If anyone asks you, simply you can say 11. So, when it comes 11 here, odd number. So if you consider as, so here 1, 2, 3, 4, 5, total is how much it is? 55, correct? Plus 11, that is 66. 66 by 11, that is 6. When you consider 6 as a middle term, so before that 5, after 6 up to 11, there is 5. So 6 is the middle term. So 6 is the average of the data. Very simple. The average of the first and last terms would be also be the average all the terms of the sequence sometimes. Clear? Okay. Now I'm taking same example. 1, 2, 3, 4, 5, 6, so on up to 11. So here, so this 11 is an odd number. We arrange it into ascending order, some 1 to 11. So the middle term is of course 6. So 6 is the average I said. Now I'm taking one more example, that is first and last terms also be average of that. So average means here for the first term 1, last term is 11. 1 plus 11, that is 12. 12 by 2 is 6. Very simple. Correct? So in this way also you can calculate the average. If x is added to all the items, then the average increases by x. Clear? So if you take 1, 2, 3, 4, 5, 5 values. So here 3 is added. 1 plus 3 is 4, 2 plus 3 is 5, 3 plus 3 is 6, 4 plus 3 is 7, 5 plus 3 is 8. 3 is added. Correct? How much increases 1 to 5 is simply, you can say is 15. So 3 is added to 5. And how much added is 15 added? So 15 plus 15, how much? 30. 30 by 5. 6. What is the previous average here? 1, 2, 3, 4, 5. So 5 is an odd number now. When 5 is an odd number, middle term will be average now. Because all the items have the same difference. Means here increased by 1 unit. Correct? So 3 is m. So how much you added for each one? 3 is added. So you have to add the 3 to the average value. Means 3 plus 3 is 6. That is very simple. Clear? So average of 1 to 5 is 3. 3 is added to each one. So average also increased by 3 units. So previously 1 to 5 average is 3. So when 3 is added to each term, the average is 3 plus 3. That is 6. That's it. In a similar manner, if x is subtracted from all the items, then average is decreased by x. If every item is multiplied by x, then the average also gets multiplied by x. If every item is divided by x, then the average also gets divided by x. This is the concept of average. These are the properties of average. Okay, so maybe you understand very well. Now we are going to see the same concept for the group data. The mean of the following distribution is 9, then find the value of P here. So X represents the observations and F represents the frequencies. 4, 5, 6, 10. P plus 7, 10. Means 4 observations for 5 times. So 10, 7, 15, 8. So for our convenience, the horizontal table we will write as a vertical table. The first one is X, second one is Y. The values will be represented by X and their corresponding frequencies are represented by F. And take Fx, the product of these two. Okay, so when you take the product of these two, that is sigma F. So in the what is the previous one, when you observe it, the sigma F, add that values. So sigma F is how much? 5 plus 10 plus 10 plus 7 plus 8, which is 40. In the previous one, if you take it as Fx, 20 plus 60 plus 10p plus 70 plus 70 plus 120. Correct? So it is simply we will say as 270 plus 10 of p plus 7. The mean is sigma Fx by sigma F. Fi xi, because it's a variables means. 270 plus 10 of p plus 7 by 40. Of course, it is 270 plus 10p plus 70, which is so 9 will multiply this. 940 is totally 340 plus 10p is 360, or 10p equal to 360 minus 340. Of course, 10p is 20 and p equal to 20 by 10, where p is equal to 2. Like it's a small application. Okay, so we are not finding directly the value of the mean. Here we are finding the mean value. If the mean is given, when mean is given, so you have to find the unknown value, that is p plus 2. Okay, p is equal to 2. Okay, now we will go to another example. The following table shows the number of plants in 20 houses in a group is 0 to 2 is 1, 2 to 4 is 2, 4 to 6 is 2, 6 to 8 is 4, 8 to 10 is 6, and 10 to 12 is 2, and 12 to 14 is 3. Then find the mean of the above data. Okay, so we have to write the number of plants and number of houses, that is frequency. Take the class mark. Here class mark means here simply a mid value. So how to find the mid value? Lower boundary plus upper boundary by 2, average of this one, and find Fx. Okay, you calculated Fx. After calculating Fx, find the sigma F value, which is 20. Find the sigma Fx value, that is 160. What is the mean for it? It is sigma Fx by sigma F, that is 160 by 20, which is 8. So there are averagely 8 plants per each house. Okay, now coming to the another one, that is by using a method called step deviation method. By using step deviation method, you are going to find the mean of the given group of data. Here we will assume the value, that is assumed mean here. It is, we will take it as for, so 50 as assumed value. I consider 50 as a assumed value, that is here, and we have to use the deviation d equal to xi minus a by c is a class interval or class length it is, and find the fd value. Okay, now we have used the formula. Here I am explaining the formula, that is a plus sigma fd dash by sigma f of c. A is the assumed value mean, and sigma is summation of the frequencies given in the group data, and sigma fd is summation of the frequencies and deviation of a given data, and d dash of course is deviation is x minus a, and c is class interval width, and x bar is arithmetic mean. Okay, so here x bar equal to 50 plus 40 by 40, just you substitute the value. So here sigma f equal to 40, sigma fd equal to 40. So obviously, so 50 plus 40 by 40 of 20, 40 40 get cancelled. So 50 plus 20, which is 70. In this manner, you can calculate the mean of the data. So mean, we can say arithmetic mean, mean, average.